Today we're going to look at conditional probability through the application of the HIV test. We have two questions here that we're considering. What's the chance that a person selected at random from the population of the U.S. is infected with HIV? And then what if that person was one of 100,000 people selected at random from the population and the test is 99.5% accurate? If the person got a positive test, what's the chance that they actually have HIV? So for the first question, we're pretty much told that in the population, based on the data, about 1 out of every 250 people is infected with HIV. But for question B, if you get a test and you test positive, and the test is 99.5% accurate, what's the actual chance that you will have HIV? So, in this case, we have to consider two situations. That you tested positive and you're actually infected, or that you tested positive and you're actually not infected. So, let's see. Based on our sample, we have, if there are, out of 100,000 people, 1 out of every 250 we would expect to have HIV, if it matched the population. So out of 100,000 people, we would expect 400 of them to be infected. And if the test is 99.5% accurate, so then for the 400 infected people, the test, if it's 99.5% accurate, so these are the people that test positive, times 0.995, we would get that 398 of them are what we would call true positives. The remainder of them, the 0.5%, so times 0.005, that would be 2. They would get a false negative. They would get a negative on the test, but that would be incorrect because they actually do have HIV. For the remainder of the people, that's 99,600 people, and they are not infected. And again, if the test is 99.5% accurate, then we would expect that of those 99,600 people, times 0.995, we would get that 99,102 of them would be a true negative, meaning the test gave them a negative and that is true because they don't have HIV. Which means that the remainder of those 99,600 people, or 498 of them, will get a false positive. They would test positive even though they don't actually have HIV. So let's figure out what's then the percentage, given that you tested positive, that you actually have HIV. So the probability that you actually are a true positive, given that you got a positive test. We have the formula from stats that you are a true positive over the total number of positive people. Okay, so how many of these people were true positive? 398 of them. How many positives total did we have? We had 398 plus 498. Those were the false positives. So this is true positive only over the fact that you got a positive test. So actually this many people got a positive test. Over 800 people got a positive test, even though over half of them weren't positive. Oops. Sorry, a little pen mark there, 896. So what we ended up with is it's about 44%. So what are the odds that you actually have HIV given that you test positive? It's not even better than a flip of a coin. A flip of a coin would say 50-50. Here we're saying if you test positive with a 99.5% accurate test, so a very accurate test, the odds of you actually having HIV are still only 44%. So Because we have so many people in our population that aren't infected, it ends up giving us a lot of false positives, even with a test that's almost perfect. Isn't this interesting? So now you should go to the discussion board and answer the questions there.